Hello. Thanks for attending this. My name is Masoumeh. I've been at Victor for the past 2 months. So I'm going to tell you about what I want my mission to be at Victor, which is going to be privacy in practice. I had a conversation with Shai earlier this afternoon. He was like, really? Is that possible? So I'm going to talk about that's my question too. And before then, though, I want to tell you a little bit about my past research and how this journey started and how I got to this point and what are the problems that I'm looking at now. I did my PhD in privacy and security in databases, machine learning, but that was not the beginning of my journey in cryptography, security, and privacy. I got my master's in cryptography, and I did a bunch of works in several different research projects. You'll see when I mention my works, there's some in cryptography and security. There are some which are like particularly during my PhD at Yaoliang Yu, which were more focused on privacy. And by that, I focused on like different notions of privacy for different applications, what's the appropriate notion of privacy and what are the limitations, and how I got to this point that I have these projects as my current projects at Victor. I mean, these are the ones they already defined, but like that I want to do during my time here. So, as I said, I worked on a whole bunch of different topics on how we can enable two parties, multiple parties, a group of people communicate securely with each other to achieve a goal. I worked on group signatures, which enables, let me give examples. So I can sign a message, send it to you. You can verify that a postdoc from Victor signed it, but there is anonymity. You won't be able, as a general verifier, you won't be able to tell who that person is. But also there will be entities who can, at the time that it's needed, open and trace a message back to the original signer. And the work that we did particularly was interesting because we separated we didn't have this central party who would share the keys, open the message when it was needed, and would like observe everything. We had different parties who would do different things. This was actually my work that started prior to my PhD at University of Waterloo. And interestingly, the second project here is the last project that I did during my PhD, which was done when I was an intern at National Research Council of Canada. The idea there was like having database operations over encrypted data, which is very tricky to do when it comes to challenging operations like equity joins. So we showed that we can perform that, and we can prevent the leakage that comes from performing a series of queries. And another work that I put here is a multi-party private intersection. Again, let me give an example of where this is useful. Imagine the banks want to share with each other that they were affected by a cyber threat. But they want to share it with other banks who are affected as well, and they want to talk about the defense. If other banks are affected, then it's a common threat. So this is like an over threshold. There is a private set intersection, but they will know about this intersection if the size of the intersection is higher than if they share, all of them share that, or a certain number of them, higher than a certain number of them share that threat, and they can talk about the defense. With that intro, I would like to switch to my research, which were more privacy-focused. I looked into different applications of differential privacy. So differential privacy is one of the privacy notions that I looked at. So when it comes to applications like average histogram and stuff, we know how straightforwardly we can apply differential privacy, but this is not possible for every database query. I looked into one challenging database queries, namely contextual outlier detection, to explore more into how it's possible to use differential privacy. I mean, I started with, is it possible or not? Or like how we can tweak different things to make it work. The other application that I looked into was differentially private two-party set operations. This inspired by this news, Google sharing information of their clients with MasterCard, which was done secretly, and then it was announced in the media. It got the media attention later. And then we wanted to look at if it's possible for two parties to have set operations, but also do that in differentially private manner so that the privacy of individuals is preserved. Another project that I looked into was looking into the robustness of watermarking in deep neural networks. I'm happy that Nicola talked this morning about the watermarking. The use case that Nicola emphasized on was to protect ownership, but we were looking into it because we thought that if watermark is robust, we can also use it as contract protection or terms of use protection. So that would help us with purpose-based privacy. If I agree with my data to be used for a particular application or a model to be used for a particular application and with not others, this could help. But again, there are questions about the robustness of watermarking network. And here that I'm mentioning is what I did during my internship at Microsoft Research. We looked into the organizational graph, and if we can learn from the communications, email communications in an organization without learning the confidential information. And I will talk about the first and the last project here in a little bit more details, but like I'm going to skip, or I'm going to have to skip a lot of details because of the time that I have. So starting with this, I said that one of the projects that I worked on was to answer this question: can we use differential privacy to protect context and contextual outlier detection? We talked to you a little bit about this. First of all, what are contextual outliers? If you want to define the outliers in your data set, it's important that what is the context that you're comparing with. Winter days in Alberta, absolutely. Summer day in California, no. Outlier release, what it does, sees if a particular data is an outlier in the data set. So it looks into the context, if this data point is an outlier, and you can consider different utilities for this context that you want. You might want to be like, what is the biggest subpopulation that this data point is an outlier in, right? The question is, what we're looking at here, don't confuse this with, we didn't want to protect the outliers. We're like, this outlier we want to reveal because they win scholarship, because they are representative of an intrusion, there is a malfunction or something. So we want to reveal, we are fine with revealing the outlier, but we want to protect context. I don't want my information to be revealed because somebody else wanted a scholarship, right? So, and I did. This is a question. But then, well, for differential privacy mechanisms, we have two main ones. We're working with numeric values. It's the noise that you use normally or approaches. And if you're dealing with non-numeric values, like context subpopulations, that's non-numeric, we use exponential mechanism. I don't go exponential mechanism, just I want to mention what are the challenges and how we dealt with it. Well, I mean, I can't even talk too much about the details of that, but like briefly mentioning that. So what exponential needs to do, forcing over all possible contexts, score them based on the utility, like the size of the subpopulation, and then selecting among weighted context. Challenge. Now, so you know that this is like a toy. And with 25 attributes, it took 3 days for the algorithm to run. And I'll take a break there to have a sip of water. So we designed this algorithm that we call definition of potential privacy the release, and it's challenging to do because you're working with outlier context. You're working with context that need to be valid for outliers. And you can't just go over all possible contexts, and that's going to be a problem in differential privacy. So we needed to tweak that a little bit. And then the complexity, we needed to reduce it from exponential, and that was possible. And from mapping this problem to a private graph search algorithm, and we could reduce the complexity. And we also showed that the privacy and scalable. So it's a good trade-off between those, and it's compatible with different utility layer detections. I have just a sample of the results that we have to representative of, like, when I say there is a good utility between privacy, utility, and performance for each. So the breadth-first search that we use, the same problem that I was talking about, that was taken in 3 days, takes 37 minutes. With this approach, the utility that it gives us is 90% compared to non-private version. And final epsilon is 0.2, which, if you're in differential privacy, you know that's like if you're looking for lower values, like normally below 1 would be ideal. So that's what we got. And by that, I'm going to move on from this, saying this, that we were able to introduce this private, accurate, and efficient solution for a problem that was not straightforward. It can have applications, as I'm going to talk about later, maybe in industry. Like, I've seen a similar problem to this. And this is like, you know, it's as a side effect of that, it was the first time introduction of private search algorithms, and it also can be extended to similar problems. I also promised to talk about the last privacy projects on the list. The work at Microsoft working on confidentiality in social graphs. And if you're in security and cryptography, you might have a different notion of confidentiality in your mind. So I might be abusing the term. So I'm going to talk about it a little bit, why I'm using this. I'm very happy that people talked about membership references. Yeah, basically ran same problem. You train a model. You don't want the model to learn. So one of the secrets of the organization, the organization that I was doing the internship at, let's assume would be like GitHub acquisition at the time, right? So the way that we as a group, the employees, connection between them, the communication between the two means that they communicated through email, and then the differential privacy here for the model not to learn the secrets of the organization, or like whatever they secreted for the organization. And when we use differential privacy, the guarantee is, when we use edge-level differential privacy, the guarantee is it's protecting that edge, right? But then the thing is, if I communicate with a team member of mine about GitHub acquisition or something, it's very likely that I talk to other team members about the same thing as well, right? So you can't just protect one edge and assume that you protect the secret. But then the assumption here is, when we're talking about it, is that we assume that secrets are talked about in teams or in groups or correlated the neighborhood, right? So the way to deal with that would be from this edge-level privacy, particularly protecting one entity, one edge in edge-level privacy, everything that is correlated to each other, right? So all of these are correlated. Let's assume that, and we consider all of that, like instead of like using epsilon, we use 4 epsilon here, and we think that we are protected, right? The problem with that is, like, if we assume that the information that we want to protect is between these two, and it might be between the other members that these two other people talked about, but the thing is, this will ruin the utility. So the question was, is there any middle ground between the two? So we decided, instead of considering on this with the connecting edges, we decided to measure and have some, like the first one is like basically, and then see what the correlation is. So the thing is, it does provide a middle ground, but the result of this project was, I can't bring the results because like it's, I will need data sets that I use a lot, and I would interested people to the paper. It was a middle ground, but still poor utility. So this refers to the limits of differential privacy, or like the usage of differential privacy in practice for other things, and how it's limited, and like to what extent we can use it for, right? So this and other projects that I worked at, like I was in both academia and industry for the past whatever years, like doing internships, my PhD, as Gautam said, I was working for a financial institute, looking into their problems. I realized that there is a whole lot that we can do with applications of privacy. Well, first of all, knowing what their problems are, what are the things that they understand. They all heard about differential privacy, I promise you. But then knowing that if the differential privacy, as I say, golden standard, but like, is it a golden standard for every single application of privacy that we have in practice or not? These are the things that motivated me for defining my project at Vector, looking into practical privacy problems. I start with the first project that I have, which is federated learning. I am fortunate to work with AI engineering team at Vector, working on federated learning for health data. They wanted to be private. I'm helping them looking practically, reasonably doable. What are we going to do when there is data overlap? Like one patient doesn't just necessarily go to one hospital. What if they go to 2 hospitals? What is it that we are protecting? So are we just, if I have multiple scans of myself at a hospital, is it going to be a data points level? So is it going to be just one of them that is protected? Or is it going to be patient level that's going to be protected? And what of us? Like, can we really? So related to that, you are a Librat student. It's a generation, it's setting, what the motivation that we have is using it for, I mean, in private version, using it for health data applications. And again, related to the other two, I was approached by National Research Council of Canada for the proposal that they have, solution for federated learning for health data that capture the privacy of individuals. The second project that I'm doing, industry. Yeah, 1 minute. So she and I, my advisor and I, have also for their concerns about privacy. Like the general ones that I can mention here would be like release. They want to be able to release the data and have analysis on that, and if synthetic data generation can help with that or not. Help them with visualization and like making their clients or third parties that they're working with the importance of privacy. And another important project for me is like looking into the relation between academia and for privacy practices. Why we have so many privacy techniques in academia. We are going to have privacy regulations and rules. We have some of them. When the industry needs to comply with those, they don't use privacy techniques. They use access control things, or like, you know, give privilege, but make sure that just privileged entities can access the data instead of using the privacy techniques. And again, another work that I like to do is continuing my research on social graph-based threat MSR, and I'm going to conclude my presentation with that.
I understand the second last slide you mentioned looking for better, like understanding things blocking industry, like, like how do you plan to understand these obstacles? Do you have any like industry partners that you think would be good to work with?
I mean, I do have industry partners that I'm currently working with. I have connected with the National Research Council of Canada as well, and I try to count on them to connect me with industry partners and Victor Institute also. And I think that's where I hope that I can be connected with more industry partners than the ones that I personally have myself. But this is something I work on.
Cool. Okay.
You want help with that?
Yeah. I mean, it always seems intimidating to me to find people who are like crossing this sort of gap. So more power to you. Yeah. Cool. Any other questions for Masoumeh?
So you just mentioned it for like for the banking industry or whatever. Like, what are the data that they want to privatize? Actually, I wondered this for a while. You know.
So the banks have all our account information, mortgage information, right? And they, but there is like one is like the internal analysis of the data that they need to do, right? And they don't want the analysis necessarily in an ideal world to have access to the plain data, right? So if the privacy of that data can be protected, that would be perfect.
It's not really for releasing it, but rather like just within the institution. They don't want the analysts. They don't want the analysts to have access to. Okay.
Yeah.
Okay. So there's not going to be any releasing the data.
Yeah.
The data and the analyst, rather than between the analyst and the public.
Yeah. Okay. Cool. Thanks.
Yeah. No worries.
I want to ask, what is the utility layer? Please, because you mentioned your like matters and I don't know, what is utility?
Utility is whatever that you expect from your model. So the previous presentation was about like in the previous presentation, it was talking about the accuracy of the model that you get, right? If you integrate privacy in it, you get less accuracy, right? And the utility assignment in the social graph that you're referring to is that
you were showing a slide about the utility that you get in your work with AES and Victoria, and it was not clear what are these numbers in your utility.
Yeah, because this is the table of
in the hour detection. So the utility is there. We work on multiple utilities, but one of them that I mentioned during the talk is that it's a subpopulation being the largest possible. So if you don't have privacy, I give you a data point. I ask you if they're an outlier or not. You give me the subpopulation, the biggest subpopulation that this person is an outlier in, right? But if it's the private version, you cannot respond with like the true answer. You will respond with something that is close enough to the answer. So the size of the population is like close enough to that, but it's not exactly. So 0.9 close to 2, or yes, 100 would be the final, that's the true answer, right? And that's nice.